Welcome to the third Eriksholm update video. Working with international academia and researchers from all around the world is actually a hallmark of what we do here in Eriksholm. And we like to think it's mutually beneficial because our focus is a little bit further away from basic science, more on the translation of research into useful clinical insights or eventually, hopefully, product innovation. Today, we're going to cover two topics as essentially examples of where we heavily invest both our time and our efforts in Eriksholm, but where we also work extensively with external academic partners. First of these is the topic of communication. Actually, this was the main topic for the second Eriksholm update video. But today, we're actually going to look at this from a different perspective, where we're going to invite in one of our external academic partners to give her point of view for working with Eriksholm. So the second topic is on auditory modelling and how we see that this quite technical field can actually bring us insights and knowledge that we can bring into future generations of hearing technology, and where we partner quite extensively with external academic partners. Interactive communication is a two-way process where we're actively exchanging messages and ideas. And it still remains to this day one of the biggest challenges for our hearing aid users out there in the real world. So I would like now to introduce Lauren Hadley, who's an Associate Professor in the Faculty of Medicine and Health Sciences, Hearing Sciences Scottish Section, which is a part of the University of Nottingham. So Lauren, welcome. So you have a background in psychology, and a lot of your research in recent years has been studying how people, I guess, make predictions in conversations. But currently you're here on a research stay, which is a part of your funding from the UK and Research Innovation, which is a part of the UK Research Councils, I think. Is that
exactly?
Correct?
Yeah.
Maybe actually a great place to start would be you to tell us a little bit about that, because this is actually a pretty prestigious funding scheme, which I'm sure you're very proud of, I hope.
Yeah, I am. So this is the UKRI Future Leader Fellowship. It started a few years ago and I got it in one of the early rounds. And this is a scheme based in the UK to allow early stage researchers to build their way to independence and to becoming an established leader in the field. And the really nice thing about this fellowship is that it's a longer one, so it's 7 years, which is almost unheard of.
It's incredible.
So I'm around halfway through now. And it's got a real focus on interdisciplinarity, which worked really nicely with my work because I come from psychology, I work a bit with linguistics, neuroscience, and then I'm now kind of more based within hearing sciences and thinking more about translation. So it's been the perfect scheme for the work I wanted to do.
Yeah, and I guess also it's led to you gaining your associate professorship, which is fantastic. So it works.
Thank you. Yes, exactly.
So maybe then you could tell us a little bit about the projects and the research that you're working on then.
Yeah, I'd love to. So I have a couple of strands of work, and one is very much the real conversation work, where I bring people into the lab and set up what is supposed to be a naturalistic conversation. So I know Lena talked a bit about that on the last update video. There's similar things going on here. And the other strand of work I have is I'm trying to look at some of the processes that are involved in conversation that often get missed in studies of speech intelligibility or speech understanding. So things like this turn taking that we've been doing, that's critical in conversation, but you don't usually have to do when you're listening to a recorded sentence and responding. And so I'm trying to think about how it is that I know what you're going to say next and when you're about to end, so I can get myself ready to come in on time. And probably just to highlight one thing that I'm quite pleased with recently, we just had a paper out, well, it's in proofs, but it will be out in a couple of weeks, that has shown what I think is the first evidence that people with hearing loss show a bit of a challenge in figuring out what someone is going to say next, that everyone is still doing it. Normal hearing and hearing impaired adults of the same age both do it, but the people with hearing loss were doing it almost 200 milliseconds later. So that's almost a syllable. So you're really at a disadvantage if you're not able to kind of stay in the front foot in conversation.
So, I mean, what would you like to see come out of this extremely interesting work?
I mean, my dream in the long term is a linguistically intelligent hearing aid. So something that can use the words that people are saying to figure out the times that listeners most need help. If you can identify the salient parts of an utterance, then you can support those over and above other times that aren't so important. So if a hearing aid could help me understand that you're coming to the end of your utterance, I could get ready to come in on time and I would have a better chance of really engaging in that conversation. And I think it's not beyond the realms of possibility, it's not tomorrow, but given the advances in speech recognition and large language modelling, it seems like this is kind of on the way. And what would be amazing for me is if my research has figured out some of the things that need support once we are able to provide it at targeted kind of linguistic moments.
So kind of helping provide almost a cue for the hearing impaired individual to be ready to be engaging.
Exactly. Yeah, if there's certain things that would help someone realise it's the end of a turn, could we emphasise those? Yeah. Or are there other things we could do to just put people in a better position to be able to take part in that conversation?
Super, super interesting. So where do you see the benefit for you staying here for your research?
Well, I think in academia we often don't realise how our research would make it into industry. That's always the goal, to have translational impact. But being here, I've been here 2 months now, I've learned a lot of things that I didn't know. And I think the continued couple of months here, I'm really going to get to grips with how you move from some basic work to it impacting a product development or the testing of a product. So that's kind of where I want to understand that world, so I'm better able to contribute to it.
Yeah. And how do you see what you're doing impacting us? What do you hope that we're going to take from your study?
I hope you're going to start using all of my methods, testing your hearing aids, and then changing how they work. In the very long term, but I hope that I am able to have real impact in what's going on and how people are supported when that becomes feasible with the work that I'm doing.
Sounds fantastic, and we would love that as well. So then how did this actual collaboration come about?
Yeah, so actually, when I first started in hearing sciences about 7 years ago, there was a big project that was going on between a couple of universities and Eriksholm, and our university was one of them. So I ended up co-supervising some PhD students across Eriksholm and the University of Nottingham, and came here a few times, got to know some colleagues, and through that realised that actually there was a lot of similarity in some of the things that we were trying to address. And when I came to write this fellowship a few years later, it seemed like a natural partner to approach to be involved in the work I was doing in my fellowship.
Fantastic. Well, thank you very, very much for your time today. It's been really fascinating to hear about your work.
Thank you. Thanks for having me at Eriksholm.
Artificial intelligence and machine learning are capturing all of our attention at the moment with various promises about how we hope to compensate in a novel way for hearing loss, how we can manage more complex, more diverse and more noisy situations with our hearing devices, and then hopefully build in more intuitive interaction between a device and our end users. However, the blind application or the naive application of, for example, just things like aggressive denoising approaches can only really take us so far in modern hearing aids, and we actually need to get more nuanced understanding and information about hearing impairment and the listening brain into our devices in order to direct these technologies to something which is really usable and realizable in the world that will bring actual benefit. At Eriksholm, we have a strong auditory modeling team whose job is essentially to try and distill the latest understanding in hearing psychology and neuroscience into some kind of tangible insight that we can bring into future hearing technologies. I would like now to introduce Johannes Zaar, who's a senior scientist in Eriksholm and has for a number of years been working in the area around auditory modeling. So, welcome Johannes. Why do you think Eriksholm should be working on what is essentially a pretty theoretical topic of auditory modeling? So why should we be doing that?
Well, I would say that actually models are ways to test theories. So you have a theory about auditory processing, you can make that into a signal processing model. You feed it the same signals that you would actually present to listeners, and then you can predict ideally what they would perceive in terms of performance or listening effort or whatever. And so in that sense, it's not that theoretical, it's actually quite applied, and also it makes these theories testable, which is quite useful scientifically.
So then how are these kind of models being used in industry today? Are we using very advanced auditory models in hearing healthcare in general or not?
As far as I know, not everybody talks about this in detail, of course. Models are being used, but not necessarily the advanced ones. So There are models being used for amplification rationales, for instance, like the speech intelligibility index. That's a rather simplistic model that basically mimics the frequency selectivity and the audibility limitations of the auditory system, and then predicts intelligibility that you would measure in listeners. That's quite good for normal hearing listeners and also accounting for effects of audibility in hearing impaired listeners to some degree. But that's also where it sort of ends, I would say.
Okay, yeah. So then, in that case, what's missing? And where do you see the big advancements being made at the moment?
Yeah, well, I would say what's missing is really what we're all trying to fix, which is that when we provide listeners with amplification to fix their hearing loss, it's not really fixed. They still have problems. So they have these sort of suprathreshold deficits, as we call them. So basically you can hear everything, but you can't necessarily segregate signals and things like that. That's really the difficulty in terms of modeling as well. So something like the speech intelligibility index could not necessarily account for that. But we have actually some advancements, quite some, in the area of physiologically inspired auditory modeling. So what's needed really is a more sort of holistic, more complex representation of the auditory periphery and maybe also the midbrain to really capture these effects. First of all, normal hearing listeners, and then going from there, working in hearing deficits and really accounting for the more subtle, not so subtle actually, differences that come with the hearing deficits.
So this is to try and really kind of understand the full spread of what we actually see in terms of real world human performance with hearing impairment. Is that the idea?
Indeed, especially when it comes to really, hearing a difference between different signals, like the one of interest, the one that's interfering, or multiple interfering signals.
Yeah. So from your perspective, what is a model and what should we be modeling?
Well, a model in this sense here is a computational model of the auditory system. So we basically have a signal processing model that mimics certain aspects of auditory processing, what we know from physiology, for instance, or from psychoacoustical testing. Mm-hmm. You feed it certain signals that you could also use in an experimental context and present to listeners, but you feed it to the model, and the model makes predictions of how the listeners will respond in terms of how much intelligibility of the speech they get, for instance. The way we can use it is actually that we use diagnostics, so we personalize the model to the individual hearing deficit, the individual listener. So we work in things like the audiogram, maybe the ACT value, things like that. And then we have a personalized representation. We can make predictions for that particular individual listener in terms of speech perception, for instance.
So in addition to a model that's really able to capture the full population, you're actually talking about truly individualized models.
Yeah, to the extent that the model is correct.
Yeah. Mm-hmm. Okay. So yeah, Johannes, you've been working in this area actually for quite some years, and I know you've been collaborating with a number of different academic partners. One of them has been Professor Laurel Carney, who she came actually over here on a sabbatical stay for some months. Maybe you can tell us a little bit more about that.
Yes, well, I mean, she can tell us as well. We did this little interview online, basically. So we've been working on speech intelligibility prediction models, especially based on her huge body of work. So she's one of the experts in the field, really, with one of the models in the field. But I would say, let's hear it from her.
Sounds great.
So hi, Laurel. Thanks for making the time. You and your collaborators have built the auditory nerve model over the past decades and kept refining it. It's one of the standard sort of physiologically inspired auditory models out there. So I've been wondering, over the past decade or so, you have been working a lot on certain aspects of this model and how to interpret it. I was just wondering if you could give us your perspective on this line of work that you have been pursuing.
Sure. Yeah. Over the past couple of decades, we've really started focusing more on modeling neurons in the midbrain, brainstem and midbrain, which get their inputs ultimately from the auditory nerve model. So that work based on physiology at those higher levels has made us step back and rethink what's going on at the first levels of the auditory system and how the complexity of the peripheral coding plays into the processing of sounds higher in the brain.
Right. And I think this work has been very inspiring to many in the auditory community and really taking a different perspective than previously done. And it's been somewhat, innovative as well. However, I was also wondering, is this the new thing now and we have solved everything, or is there some unexplored area in auditory science and auditory modeling that you could refer to here as well?
Yeah, definitely. Our newest area has been to try to incorporate the so-called efferent systems, the half of the auditory system that descends from the brain back to the ear and controls the sensitivity of the ear. So we're very interested in understanding that better. It's poorly understood and it's very difficult to study experimentally. So we feel that the models can play an important role in, helping us decipher what's going on with these systems, how they work in the normal hearing listener, and then how they're affected by hearing loss.
Yeah, it's fascinating. And you have set up a study group actually around that topic, bringing together people from different sort of subdisciplines in the bigger field. Can you speak about that a little bit?
Sure, yeah. I was a fellow at the Hanse-Wissenschaftskolleg in Delmenhorst, Germany, and there with my co-host, Christina Koppel from the University of Oldenburg, we were able to initiate a study group that will, over a 3-year period, we'll bring together leaders in this field from around the world. We started with a kickoff workshop in November of 2024, and it was the interest was fantastic. People, everyone we invited basically agreed to come, and then we had additional participants that filled the entire venue, and it was exciting. A few days of discussion and talks about the efferent system from all different angles, from molecular, anatomical, physiological, and including computational modeling, which is the part where I can hopefully contribute to that group.
Yeah, I agree. Fascinating event. I was so lucky to also be in attendance. Finally, we were so lucky to have you here actually as a visiting scientist for 5 months last year. And I was wondering about your perspective on that stay and sort of the contrast between your usual academic life and the private sector research institution life that you experienced here and the work we've done together.
Yeah, it was a wonderful part of my sabbatical last year, was to be able to just completely focus on doing research, which is a big difference from the academic life. And I also just was interested to get a peek into the private sector world of research. And as you know, we focused on a fascinating result, the ACT test, which has been very successful in trying to predict how individual listeners will perform with speech in a noisy environment. And I'm convinced that with computational modeling, we'll be able to really try to understand better how listeners do that test, how it's impacted by hearing loss, and get some new insight on speech coding, especially in noisy situations, which is the big puzzle for all of us.
Indeed. I very much look forward to doing that in our collaborative project in the future years. Thanks very much for joining.
Thank you very much. Bye.
So yeah, that was super interesting to hear your interview with Laurel. So how then do you see this work sort of feeding into this vision of more intelligent devices making use of somehow machine learning in the hearing health industry?
Well, I think it really helps us understand things better, so we can get a deeper understanding of auditory processes that are relevant for, say, speech perception or other things, hearing and noise, things like that. And once we've identified those, we can actually flip it and say, okay, now this is what we need to invert in some way to the extent it's possible. With that, actually, machine learning approaches can be super helpful. It's just about what do you need to optimize for, basically. And I think for that, modeling, also just experimental work, of course, can help us really to provide this information. There's more, though, actually, we can do with the models. So this is sort of the long-term goal, I would say. That's very ambitious, and it'll take a few years.
Yep.
But to the extent we can already actually predict outcomes in individual listeners based on their diagnostics, like speech intelligibility, for instance, we can already perhaps improve what we prescribe listeners with, so feature prescription in hearing aids. Another sort of mixed form of these two things is basically when you have the model in the loop, which has been talked about a lot in the community, where you basically have an ongoing real-time model in the hearing device predicting what the listener probably perceives and maybe how parameters should be adjusted in direct reaction to that.
Super interesting. Thank you very much, Johannes.
Very welcome. Thank you.
Thank you very much for your attention. As always, if there's a topic that you would like to hear more about, something you've seen on our website, for instance, please reach out to us. We'll be very happy to try and accommodate. And with that, hopefully see you later this year.